In this chapter, you will learn energy basics, calorimetry, and enthalpy. In this video, you will learn the energy basics. Energy is the capacity to supply heat or do work. There are many different types of energies. For example, potential energy, kinetic energy, electric energy, nuclear energy, mechanical energy, and thermal energy. So what you have already seen may be potential energy and kinetic energy. Those are the ones that usually people learn from their beginning science classes. The law of conservation of energy. That means during a chemical or physical change, the energy cannot be created or destroyed. It can only be transferred from one form to the other. What is a form? For example, it can be converted from potential energy to kinetic energy or potential energy to thermal energy. But it cannot be suddenly destroyed or created. The whole system, the energy will be conserved. When talk about energy, the first thing we need to know is thermal energy has to do with temperature. So what is temperature? Temperature is a quantitative measurement of hot or cold. So for example, as for the fluid, fast-moving molecules will have a higher thermal energy, and slow-moving molecules will have a low thermal energy. That's why we call that cold. Here is an example. Let's say I have a cup of water. This is a hot cup of water. This is hot. And I have a cup of cold water. Cold. What happens if I put a drop of, let's say, a blue ink in here? I put a drop of blue ink and allow the drop of blue ink to diffuse into these 2 cups of water. Which one will be diffusing faster? Of course, the drop in the hot water will diffuse faster. Why? Because when it's hot, the molecules will move faster. And when we talk about temperature, there are different ways of measuring temperature. And the device that used to measure the temperature is called a thermometer. There are different types of thermometer. The one that you see over here, this one over here, actually both of them are based on the thermal expansion. For example, over here there is a tube and there's a big reservoir over here. It contains liquid. And when you heat it up or when the surrounding temperature is high, then it's trying to thermal expand, and therefore this reading will be higher. And when it cools down, then it's trying to drop. The problem with this type of thermometer is, let's say it is made of water or alcohol. When it gets hot, let's say at 200 degrees Celsius, then the liquid will start boiling. Actually, in 100 degrees Celsius, it will start boiling as for water. So with this type of thermometer, you cannot measure the temperature of anything higher than, let's say, 120 degrees Celsius. Okay, so what about this type of thermometer here? So it's made from a bimetal tree, like this. Let's say I have 2 different metals. For example, on the left, I have iron. On the right, I have copper, and I mount them together. I glue them together. Let's say the copper will thermal expand more than the iron. So what happened is, now it's at room temperature. If I heat this up, since copper will expand more than the iron, so after I heat it up, it's going to bend like this, because the right side will be longer than the left side. And if I have a long enough bimetal strip, then it can show a big significant difference over here. There are other types of thermometer. For example, a thermocouple. Some of you may have heard about it before. That is based on the different voltage when you have two different metals to contact together. Let's say I have one piece of metal on the left side and one on the right side. And if I just measure the voltage at the two ends, the voltage will be depending on the temperature. The other type of very famous one for the laboratory use is called RTD. So that is a coil of metal, and the resistance will be different. The resistance will be is depending on the temperature. So that's another way of measuring the temperature. And when you go to the doctor nowadays, how do they measure a temperature? They have a device just point on either on your forehead or on your ear. So how does that work? It looks like a thermal thing like this, like a gun, but touch this space, touch your skin or forehead, and it can measure the temperature, or even without touching. So what happens is it collects the distribution of infrared radiation from your body. When they analyze, yes, it can tell what temperature you are. Now we are talking about the heat. Okay, so in this case, I'm going to ask you a question and see what you think. At night, let's say overnight, outside is very cold. Let's say it's 26 Fahrenheit. So in the morning when you get up, you go outside. You try to touch a tree that is right out the door. And on the staircase, let's say you try to touch the metal. You touch the metal over here. So which one will you think it will be colder? The tree, so when you touch the tree, is the tree colder or the metal over here will be colder? Well, for you, you will feel the metal is colder. Why? Because you just feel it, okay? So you may tell me, okay, so the metal, the temperature of the metal will be lower than the tree. And the answer is no, that's not true. What happened is they both will have the same temperature. It will be 26 Fahrenheit. So how come that we feel colder when we touch the metal on the metal bar on the staircase than when we touch the tree? So it has to do with the heat, because the metal will absorb the heat from your hand faster than when you put the hand on the tree. So what is the heat? Heat is the transfer of thermal energy between two bodies at a different temperature. That means heat must be transferring from high temperature to low temperature, always. Okay, so let me give you a more understanding about the heat. Let's say on the stove, you have a big pot and you have a small pot. Let's say we fill it up with water. And I want to boil the water. I want to heat it up to boiling point. Which one I need to burn more gas in order to boil it? Of course, the bigger pot over here. So what we can say is the bigger pot of water will require more heat in order to boil, to heat it up to that temperature. Okay, this diagram here shows how temperature can transfer, the heat can transfer from a hot subject to a cold subject. See, over here, the red one represents a hot subject and the blue one represents the cold object. So when you have those two put in contact, you are going to see heat transferring, and after some time, we call that at equilibrium. That means the temperature of the two objects will be the same. I would like to talk about exothermic and endothermic. This is very important. So what is exothermic? A change that releases heat is called exothermic process. On the other hand, if the process absorbs the heat, that's called endothermic process. I'm going to give you some examples. Let's say I want to boil this pot of water. Okay, so what should I do in order to boil the water? I have to heat it up. So the water has to absorb the heat in order to boil, to get hot, boil away. In that case, we call that the water is going through an endothermic process. Endothermic. Okay, so let's try one that is exothermic. So if you have water over here and you want this water to become ice, what can you do? You are going to extract the heat. You're going to take the heat out. You're going to put it in the refrigerator so you can take the heat out. So this process, you have to release the heat from the water. This process is called exothermic. Let's look at this problem. Which one of the following is an endothermic process? Let's look at this. If you want to melt the ice, do you need to give heat to the ice, or you want to take heat out from the ice? Well, of course, give it the heat. Why? Because if you put it into the oven, then the ice can melt. So this one, it is endothermic. Water freezing. You have to take the heat out from the water, then it can freeze. So it's called exothermic. Boiling of soup, you have to put heat into it in order to boil it. So boiling is endothermic. Okay, so both A and C will be endothermic. Now, when we talk about heat, so what is the unit for heat? Here it is. Maybe some of you have heard about it before. It's called calorie. The definition of 1 calorie is to heat up 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. Or roughly, it's about increasing about 1 degree. But strictly speaking, from 14.5 to 15.5 is different from, say, from 85.5 to 86.5. Strictly speaking, there will be tiny difference. But in general, maybe it's not noticeable with our measurement, with our thermometer. So let's make it very general now. Okay, that means it's the energy that required to raise 1 gram of water by 1 degree Celsius. Okay. Strictly speaking, is at that temperature, but generally speaking, just raise the water temperature up by 1 degree Celsius for 1 gram of water. Because sometimes when we see a big calorie, so we use kilocalorie. When do we use that? And look at this. When you have kilocalorie, then you just put a capital C. Okay, so when you have this, the lowercase c, that means 1 calorie. And with the capital C, that means 1,000 calorie. So in the food business industry, they are very smart. On their label, instead of telling you how many kilocalorie, they just say how many big K calorie. That means it is 1,000 calorie, but they don't put 1,000 in the front. They just put a capital letter. So when you read the label, make sure that you understand that it is a kilocalorie if you see a capital C. Another unit for heat, it is joules. And as for the SI unit, joule is the SI unit for energy. So what is joule? Why do we have 2 different units? Joule is from the mechanical energy. So 2 different group of scientists at different time. So the physicists, they study mechanical energy, and they find out that joule. So what is 1 joule? 1 joule is apply 1 Newton for 1 meter. If you push an object by using 1 Newton and you push the object for 1 meter, so that is 1 joule. At the same time, the other people studying thermochemistry, they find out is calorie. So they are equivalent at some point. How do I know? 1 calorie will be equal to 4.184 joules.